Hey, today we have on the board a very interesting integral. It's very similar to an integral I did a few days ago, but there's a couple of important differences that are going to make this more challenging. So to start with, we're going to do something similar to what we did in the last video to start. We have the same problem where we have different angles, right, 21 and 13, but also large angles that we can't simplify using a double angle formula. For our first step, we notice we can take a 1/6 out of the denominator. We'll have a 1/6 here, and we can cancel this out. And then what I'm going to do, we have this problem in the numerator that we're going to deal with where we have different coefficients. But the denominator is a little simpler, so we'll start with this. So we have this different angle formula on the board. What we can do, just to get into a form that I like a little better for this problem, is we can multiply both sides by 2, and then this will cancel here and we'll just have a 1. So then when we do that, we'll notice that this is in basically the exact same format as this, where a plus b is going to be 21x and a minus b is going to be 13x. And so what we do is we can just have a little equation of two variables and two unknowns to solve for a and b, and then we can take it from this format that we have here and put it into this format, which I think is going to help us out down the road. So we'll add these two equations together. We'll have 2a, the b's will cancel, and we'll have 34x. So then our a is going to be 17x. Then we could subtract both equations, or we could just plug this back in here, and we'll see that our b is going to be 4x. Then we'll take these values, plug them back into our identity here. So we'll have our 4x there. This a plus b is our 21x that we have here, and this a minus b is our 13x. So what we'll do is let's just clean it up and we'll rewrite this with using this new identity here. Now that we used our identity and found our values for a and b, we've now transformed the denominator into a product where we had it as the sum of two terms before. When I did this the other day, the first thing I was thinking was we could then actually split this into two integrals. And then I was thinking, oh, we'll have some nice cancellation. But if you look at it, actually we won't, because the angles are different, right? We have, like, if we have cosine 21x here, there's no cosine 21x here, and the same thing with cosine 13x. So if we separate this into two integrals, that's really going to make the problem worse. So the next thing I wanted to do is see if, why can't we just do basically the same thing we did on the denominator in the numerator and use an identity. So we have this different angle identity for cosine that is pretty close, because you'll notice, okay, we have the same a plus b, a minus b configuration. This can be our 21x, this can be our 13x. And then we could transform it like this, and then we could have cancellation. The only problem is it's the coefficient. So we don't have, this isn't 1 and 1, it's 3 and 5. Now if it was the same, we could just multiply through by a 3, but then we'd still be off. So what we're going to do is we need something else so that we can just deal with this different coefficient situation. So what we can do is we can bring in this second identity, where instead of it being a sum of two cosine values, we have a difference of two cosines. And instead of this being a product of cosine, we have a product of sine. So maybe if we use these two equations together, we can somehow create this numerator this way. But at first, it's not really clear how we can do that, because if we add these two lines together, these terms with the a plus b, which is our 21x, these will just cancel out, and we don't want that. We want 3 of these. Or if we subtract them, we lose the other term. What I can do is I can take this top line and multiply each side by m. So we'll just distribute it to both terms, and we'll have an m here. And then in this second line, we can do the same thing, multiplying through by an n, just inventing a variable. And now if we add these two equations together, we're not going to lose terms, because the m and n are different, so nothing's going to cancel out, but we're going to be left with, we'll have an m plus n value. This coefficient is going to need to equal the coefficient on our 13, right? Because our a minus b is 13x, and we already found how to solve that when we did the denominator earlier. And then so m plus n is going to need to be the coefficient on the 13 term, which is 5. So we're saying m plus n is going to be 5. And then here, when we add these two together, we're going to have n minus m, and that's going to be the coefficient on our 21x term, a plus b being 21x. That coefficient is 3. So again, we just get a simple system of two equations, two unknowns. We can, let's see, if we add these together, we'll have 2n equals 8, so our n value is going to be 4. And then just kind of by inspection, we can see that m must be 1. So now you can see it looks like we made things much worse, right? Because we had to use two identities. So now we have this huge numerator. We have, so here's the 1 is our m value that we found on the last board, and the 4 is the n value. But even though it seems more complicated, the thing now is we have identities we can use, right? Because these coefficients are the same here, here, and here. I mean, in sets, right? We have 1 and 1, 4 and 4. So then we can use our identity to replace this value and this value. So now we've transformed the numerator using the identities from the previous board. We have, so I tried to make this explicit that we're using, this is our m value that we found, and this is our n value that we found. And then we had the two formulas for the sum and difference of cosine angles, so we're just using those formulas. And then notice our angles stay the same, 17, 14, the same as we had here, here, and here. And don't forget the dx, because you guys will give me a hard time in the comments. That's a dx factorial right there. So next we'll notice this 2 times 4 is just an 8, and what I'll do is I'm going to rewrite this, but now we can break it into two integrals because I think we then will see some cancellation. Now we've split this into two separate integrals. I took the 1/6 here and distributed it into each integral. Okay, and so now this is the fun part, is we can do some cancellation. So first the 2's will cancel here. Sine 17x will cancel here. This is going to be tangent of 4x. Then here, 8/2 is just going to be a 4. Cosine of 4x, these will cancel, and here we'll have cotangent 17x. So then we can integrate. We just need to remember that we have this coefficient on here, so we're going to have to bring that out as a constant when we integrate, like kind of a quick u substitution in our head. So here we'll bring out a fourth, and we'll have 1/24. And then the integral of tangent of 4x is going to be natural log of secant 4x. Then here we're going to have a 17 that's going to come out. What I'm going to do actually first, let's cancel the 4 with the 6, and we'll have 2/3. So 2 times, we'll have a 2, and then 3 times 17 is going to be 51. And then for the integral of cotangent of 17x, we're going to have natural log of sine of 17x plus c. I'm gonna check my answer because that was kind of a lot of work. And that's our answer. Let's box it. So as you can see, having a different coefficients here in the numerator actually made quite a bit more work for us. But still, pretty interesting problem. I'll stop it there. Thank you guys for watching.